So how many shapes did we see?
Um, we saw the linear, the trigonal, tetrahedral, and the octahedral.
Okay. What else did we see last week? We saw the structures, right? How they were, the angles also we saw, right?
Yes.
At what angle they are all placed when we talk about linear, dihedral, right? Everything. Okay, fine. So today what you want me to do?
Organic.
Organic chemistry,
Yes.
and any specific topic under organic chemistry?
Um, no, nothing specific. Just like start from basic.
Okay, 1 minute. You have sent me your syllabus, right?
Yes.
Yeah, I'll just have a look over it then. Okay, organic chemistry. We had what is it? Different types of formulae, nomenclature. Okay. Organic chemistry. Now, organic chemistry. What do you understand by organic chemistry? What do you understand by the term organic?
Um, Something that happens originally.
Sorry? Can you be a
I'm
little
not sure.
louder, please? I'm not able to hear you properly.
I said I'm not sure.
Okay, you're not sure. Organic. Organic means anything which is occurring naturally. Okay? Anything which is occurring naturally. So, naturally occurring chemical objects or chemical subjects or chemical substances we are going to see in organic chemistry. So, there are few examples of organic chemicals. What are these? They are known as the alkanes. Then we have alkenes, we have alcohols, carboxylic acids, and there are few more. Okay, to name the basics are alkanes, alkenes, alcoholics, and carboxylic acids, and they are the different homologous series of this organic compounds. Okay, homologous series. What do you understand by term homologous series?
What formula? Homologous?
Sorry. Homologous series. Do you know what do you mean by homologous series?
Is it I'm not sure, but is it like the splitting?
Yes. What is that? They all have a same functional group. They have a same functional group. Also, they have similar kind of chemical properties. Okay. Homologous series are the family of organic compounds that have same functional group and they have similar chemical properties. Got it? Okay, so this is general view on organic chemistry. Now we'll see what are the different types of functional groups and what are there in the homologous series. Okay. Now functional groups. What are functional groups? Functional groups are often used to functionalize a kind of a compound depending upon the physical property as well as the chemical property. Okay. What is functional group? They are used to functionalize a compound affording it different physical and chemical properties. Okay, functional groups are these, and these functional groups, they have to undergo same type of reactions. Okay, whatever their compound it is, but they have to undergo a same type of reaction, and these functional groups can be used to distinguish similar compounds from each other. So second point of functional group is they undergo same type of reaction. They are used to distinguish similar compounds from each other. Okay, you understood this? What do you understand by a functional group? So how many functional groups we have and what are the different functional groups? Okay, we have many functional groups. Like I said, we have alkenes and alkanes and alkenes are the basic ones. Then we have alcohols, carboxylic acids. So I list them. We have alcohols. Then we have carboxylic acids. We have ethers, carboxylic acids. Then I think we have esters when we are talking about ethers, ketones. Then we have aldehydes, ketones. Then what else we have? carboxylic acids, esters done. So these are the few of the functional groups, okay? Few of the common functional groups which we will be studying. Okay, we also have amines, but we won't be going deeply into everything. We will be doing only the ones which are there in your syllabus. Okay, so you understood what is a functional group and the different functional groups we are going to see. I think you have only alkanes and alkenes along with carboxylic acids, I guess, if I'm not sure. Okay, so we will do alkenes and alkenes. Now we'll go to the isomerism, that is structural isomerism part. Have you understood this part? Luna, have you understood the things we have done till here?
Yes.
Okay. Now, under your topic, our next topic here is structural isomerism. Okay. Now, tell me, what do you understand by the term isomers?
It's like compounds drawn in different ways.
Sorry, can you be a little more loud?
Is it like when two molecules react and they form like a one large product molecule?
No, isomers are not that, but isomers are one particular molecule. You said two molecules when they react, right? No, isomers,
Yes.
they are molecules. They have the same molecular formula, but they have a different structural formula. Okay, they have same molecular formula, but they and different structural formula. That means the arrangement of the atoms are different. Okay. Now, what are structural isomerism? I told you. In structural isomers, what is happening? The atoms, they are completely in different order. Okay, we'll see one. And under this structural isomerism, we still have many categories under it, and we'll see one by one. Okay. So the first one under structural isomerism is the chain isomerism. Okay. Now, what do you understand by chain? Chain, or even they are known as linear isomerism. Linear means when they are in a one straight line, right? Now, these isomers are there because of the possibility of branching of carbon chains. Now, okay, I think this you will be doing only if you understand alkanes. Okay, fine, no problem. I'll write. A homologous series, they start with one carbon atom and a hydrogen bond atom. Okay, whenever we are talking about organic chemistry homologous series, we have elements of carbon and hydrogen. Okay, now CH4, this is methane. Okay, CH4, C2H8 is ethane. Do you know the names of the alkanes?
Is the third one propane?
Sorry?
Is the third one propane?
No, all the names under alkanes. Do you know all the compounds which is coming under alkanes?
Methane, ethane, and propane. I'm not sure about the fourth one. Is it butane?
Butane, yes. So C2H6, it is not 8, it is H6. Then C3H8. Then comes C4H10. So these are the butane and propane. Okay, methane, ethane, butane and propane. For time being, we'll only see till propane. Okay. Okay, I'll write also of pentane. Maybe this will be also of a handy. This is pentane. Now chain isomerism. CH4. Now methane is the smallest compound over here, right? So CH4 will be written as it is. Ethane, C2H6. So C2H6 can also be written as CH3, CH3, right?
Yes.
Butane. How can butane be written down? 1, 2, 3. We have 3 carbon atoms, right? 3 here, 3 here. Okay, right? C3H8. So these are chain isomerism. That means we are just pulling it up like this. Okay. What about propane? C4H10. That will be CH3, CH2, CH2, CH3. So you understood what is a chain isomerism or a linear isomerism? Compounds or the structural formula which we are just writing in the form of a chain. Okay, got it?
Yes.
This is chain isomerism. But here we are not allowed to put branches. Simple chain. Even if I am talking about, we saw butane, propane, pentane. Even if it is pentane, it will be simply like this. Okay. So these are examples of chain isomerism. You understood this one?
Yes.
Okay. Now, with this chain isomerism, we can also twist it. Once they are chains, our chain isomerism should have a longest number of carbon atoms, right? So this can be put in this way of also. If I'm talking about butane, I can write it as this way also, like CH3, CH, CH3, CH3. Okay, this is also this is also propane, right? This is propane I'm talking about. Now propane, which is the largest chain should I consider here?
CH3, CH, CH2.
So I should take a chain, right, which has the highest number of carbon atoms. So I have 3 possibilities here. I have 1, 2, 3. Either I can take this as my longest chain this way, or I can take 1, 2, 3. I can consider this also as my longest chain, or I can say 1, 2, 3. I can consider this also as my longest chain. Okay. I'll show you one more example. If you have not understood this better, I'll show you one more example. Have you written down these parts? Hello?
Yes, I wrote everything down.
You have written them down? Okay. like I just told you about butane, right? Let's see how we can write it for a pentane. I'm taking pentane. Now pentane has how many carbon atoms? Pentane has how many carbon atoms?
5.
5. Okay. So the formula will be C5H12. Okay. So first structure I can write of a pentane is of a chain one, a linear one. CH3. Okay. So I have 5 carbon atoms and 12 hydrogen atoms. Second one I can write it as CH3, CH2, CH, CH3, and here I will put a branch of CH3. Now again this is also a pentane, right? Only because it is having 5 carbon atoms and 12 hydrogen atoms, right? Okay. Now which one do you consider as the longest carbon chain?
CH3, CH2, CH, CH3.
Can you mark it and show me over here? Okay, that one. Okay, you want to consider that one. Fine. Okay. Why? Because I have 4 carbon chains over here and that's why you have considered over here. I have one more choice of putting this way also, right? 1, 2, 3, 4. Yes. This also has 4 carbon. This also has 4 carbon. So I can consider this as also my longest chain. This also my longest chain. But if I had to consider this, will this be my longest chain over here? Oh, right? Why? Because I have only 3 carbon atoms comparatively to this both. Okay. So this was the first structural isomer. This was the second type. And third, pentane. We can also write the pentane in this manner. Again, I have 5 carbon atoms with 12 hydrogen atoms, right? Yes. I have 5 carbon atoms with a 12 hydrogen atoms. Again, this is a pentane, but I have made it in a twisted version. That means I have just branched it like this, right? Now, which is my longest chain over here?
That's the longest chain.
Okay, you want to consider this only because they have 1, 2, 3. But in this structure, we have many long chains, right? This is one long chain as you told me. I have 1, 2, 3. This way I can consider, or I can consider this way 1, 2, 3, 1, 2, 3, or 1, 2, 3. So I have many ways 1, 2, 3, 4, 5, 6 ways I have. 6 ways in which I can identify my longest chain, right? So these are all called as structural isomers. Okay, we are taking only one compound and we are putting the different structures which are possible. Understood? Okay. Next, we'll move on to what are known as position isomerism. Now in position isomerism, what is happening? We are just going to add an extra functional group to it. Okay, we are just going to add an extra functional group to it. We'll take one example like C3H7Br. Now this is bromopropane. Okay, bromopropane from propene, right? C3 is propene. So from we get bromopropane. Now how can I write this structure? First method, how can I write it is CH3, CH2, CH2, Br. Right? This is my first possibility. And how will I name it? This will be 1-bromopropane. How I got 1-bromopropane? We should always start with the numbering of the chains from where it has been attached. So bromine is attached from this carbon atom, right? So my chain will also start from this way. So since it is attached to the first carbon atom, I will say as 1-bromopropane. Okay. This can also be written as CH3 and a Br here. What I have done, I have just moved down my bromine to my second carbon atom, right? So again, my number of carbons, my number of hydrogens and my number of bromine, they are all same. But only thing is I have just moved the position of the bromine. Now, numbering of the longest chain. So since it is in the middle and I have only 3 carbon chains, I can name it anyway, right? 1, 2, 3 this way or 1, 2, 3 this way. Now tell me to which carbon atom is my bromine attached to? Number 2, right? So we will name them as 2-bromopropane. Okay, it is known as 2-bromopropane. So what did we attach here was we attached a halogen group. Now let's see if we attach an alcohol group. Second example we will see. Let's talk about C4H9OH. So this is butanol. Okay.
Just a second before you move on.
Which one?
Before you move on, I just wanted to ask, why did you call it propane?
3. Sorry, that means I made a mistake over here. Okay, sorry. Butane. Butane is 4. This is propane and this is butane. Whenever we are having 3 carbon atoms, it is propane. And when we have 4 carbon atoms, it is butane. Okay? Okay, what I'll do is when we are doing alkanes, we will see about all the elements coming under them. Okay? All the compounds coming under them. Okay. So you understood this part?
Yes.
Okay. Now, how are we going to put this one? This is butanol. Butanol, why? I have C4, okay? 4 carbon atoms and I have an alcohol. It is a butanol. First possibility, as a linear one, I will put it. So this will be CH3, CH2, 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 OH. Okay, this is okay. General name is butanol. But now since I have put it in this way, how should I name them?
The OH is attached to the first carbon atom.
Which is my longest chain. This is my longest chain, right? Since it is a linear one, I have one longest chain only. And we are going to consider the first carbon atom to which my alcohol group is attached. So naming butanol or a compound which has alcohol can be done in 2 ways. Okay, first method I tell you, since we know it is a butanol, what we'll write is butanon, okay, hyphen, and which carbon atom is my alcohol attached to? First carbon atom, right? 1, 2, 3, 4. So butane 1 all. You understood how to write the name here? Let me see. You tell me what should I name this one.
Be butane 2-ol.
Yes, it is butane 2-ol. You got it? How to write this? Now these are only two examples of butanol. There are still many more isomers which we can form with the help of butanol. So tell me, once you're done with these parts, I'll go on to the next slide.
Finished.
Finish? So we were talking about butanol. Now butanol can be also written in this way. Okay, this is one possibility. Also, since it is butanol, I can also put it as this way. Now, how can I name this one? Now, first we have to consider the longest chain and the smallest carbon atom to which my alcohol group is attached to, right? So, which one do we consider as the longest chain?
CH3, CH, CH2.
Okay, this one, the linear one, this way. So, it will be 1, 2. So, this will be 1, 2, 3, right? We cannot consider this one. We can consider this one also, 1, 2, 3 also. Like this also we can consider, right? Either this is the longest chain, this one, or we'll consider this as the longest chain. But we cannot come from this side, okay? Because that will be, alcohol won't be attached to the smallest carbon number. So we will consider any of these. Any of these, I think we will be getting the same name. Okay, now, whenever we are having this kind of a compound, wherein we are having a branch of the same homologous series, we have to name them according to them. Okay, now tell me, this is my longest chain. Okay, I'll consider this as my longest chain. To which carbon atom is my methyl group attached to? Second. So I will write 2 hyphen. And what is the name of my longest carbon chain?
Propane.
Okay. Now second, methyl, right? It is methyl group attached to it. So first I will write the attached group, methyl and propane. But not propane, but propane. Okay? Propane. Now this propane is attached to one alcohol, right? You remember how we wrote butane 1-ol? So we will write that way. So it will be 2-methyl propane 1-ol. That means alcohol has been attached to the first carbon atom. Methyl is attached to the second carbon atom. Got it? So what will you name this one?
It's 2-methyl propane 2-ol.
Very good. It is 2-methyl propane because if I consider this as my longest chain, methyl has been attached to my second carbon atom as well as alcohol group attached with my second carbon atom, right? Even if I consider 1, 2, 3, it will be the same thing, right? So this is positional isomerism where we are having positions. So I am shifting my positions, okay? So how I'm naming it, it depends upon this. You understood this part? Now, third type is functional group isomerism. Now, the name itself suggests we are going to add a functional group to it, right? We saw many functional groups when we were discussing this. Like we have alcohols, we just saw alcohols, there are carboxylic acids, ethers, ketones, esters, aldehydes, amines and all. So we are going to add one kind of functional group to our compound here. Now first example we'll see is that of C3H6O. This is my molecular formula, but since it has only one oxygen, this can be considered as an aldehyde or it can be a ketone. Okay, if it is an aldehyde, it will be known as propanol. Since it has 3 carbon atoms, it is known as propanol. If it is a ketone, it will be known as propanol. Understood? C3H6O. This is a molecular formula. This can either be an aldehyde or it can be a ketone. If it is an aldehyde, it is known as propanol. If it is a ketone, it is known as propanol. Fine. Now we are going to write the structures for both of them. We are going to see the structure of propanol and we are going to see the structure of propanon as well. First we will see that of propanol. Propanol will be this is propanol. And propanon will be C double bond O CH3 CH3. Okay, propanol, we have C3H6, 1, 2, 3, 3 carbons, 4, 6 hydrogen and 1 oxygen, which is a double bond, that is a aldehyde, and this is a ketone. Okay, now this can also be a alcohol because what we have is a oxygen over here. If suppose it was not an aldehyde, if suppose it was not an ketone, what can we write is we could have added a carbon-carbon double bond and OH group. Let's see how it would be. C2 double bond CH, CH2 OH. So I have 3 carbon atoms, yes. I have 6 hydrogen atoms, 1, 2, 3, 4, 5, 6, yes, and an oxygen with a double bond over here. Okay, this was an exception thing. If it was not a aldehyde or a ketone, it could be an alcohol with 1 double bonding over here. Okay, so this was an aldehyde. Now we'll get another one. Second example. C3H6 and O2. Okay. Now we have 2 oxygen, right? That means they can either be a carboxylic acid or they can be an ester. So if it was a carboxylic acid, it will be known as propanoic acid, and if it was an ester, it will be known as methyl ethonate. Okay, if it was a carboxylic acid, it will be known as propanoic acid, or if it is an ester, it will be known as methyl ethonate. We'll write the structures and we'll see. First, we'll see of propanoic acid. So propanoic acid, it will have a carbon double bond O. This is COOH. Okay, sorry, not H. COOH. Okay, acetic group with CH2 and CH3. So this is my propanoic acid. And CH3, C, double bond O, O, CH3. This is my methyl ethonate. You understood?
Yes.
So you understood how the functional group isomerism is working. So what functional groups we saw? We saw one of aldehyde, we saw one of ketone, we saw carboxylic acid, and we also saw ester.
Okay. Can there be a third exception for this one or no?
Sorry?
Can there be an exception for this one or no?
No, this one we don't have any exceptions like where we had here, okay? Because here what happens is we have two oxygen group, right? And that is the reason we don't have any kind of exceptions over here. It will be either a carboxylic acid or an ester. Okay? Done with this?
Yes.
So you have understood the concept of isomerism, starting with structural isomerism, the chain part, yes? Chain isomerism, how chain isomerism can be written down in this format, then position isomerism, okay, then functional isomerism. Okay, what I'm going to do is, I'm going to give you few questions and I want you to solve them, okay? First one. This is your question. Okay, you can use the board to draw, or you can put it in your paper as well, and then we'll discuss of how these substructures have happened. You got
I got only 3 structures.
only 3 structures
Yes.
of the first one.
Yes.
Okay, what are the 3 structures?
Hydrogen.
Yes. Even if you do not write the hydrogen bonds, you can just put like this: carbon, carbon, carbon. This way I can understand it. Write down the 3 structures. I will tell you the 2 other structures which you have might missed.
For the second one I drew, I drew it twice, but I had different edges.
Since we are talking about C6, 1, 2, 3, 4, okay, 5, 6. This was 1, 1, 2, 3, 4, 5, 6. Okay, this was the linear one, and you had the structural one. Okay, now this can be put it down this way also: C, 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 5. Okay, 5 carbon and 1 carbon attached to any one of a carbon here, right? This can be 1. Okay, if this is 1, this is 2, this is 3, fourth one can be, this can be 4th, right? Fifth one can be this way: 1, 2, 3, 4, 5, 6. Okay, these are the possibilities of the structural isomers. First one, got it? The rest two, I want you to do it for homework so that we can see this in next class. Okay, will you be doing these two for homework then?
Yes. Okay.
Okay, have you written it down?
Yes.
Okay, fine. So then we'll conclude here and we'll meet in next class. Okay,
Thank you.
thank you.